Good day, Ma'am Alma Patria. Today, I will present to you, together with my groupmates, the activity number 6, which is the periodic table. So before we proceed to the discussion, I will state to you first our objectives in this presentation. Our first objective is to discuss the various parts of a periodic table in terms of its periods, key information, groups, and subgroups. Second is to discuss the meaning of inert gas, including its characteristics and nature. Third is to give the common characteristics of metals and nonmetals. Fourth is to distinguish metalloids from amphoteric. And lastly, to explain the 20 elements starting with lithium and proceeding from left to right, row by row, in order of increasing atomic number. The periodic table has 7 horizontal rows or periods. The first period consists of hydrogen and helium, which is hydrogen is located at the top of the periodic table above the first column, while helium is located on the top of the last column to the right.
The second period begins with lithium and ends with neon. How many elements are there in this period? So in the second period, it starts with lithium or Li and it ends with neon or Ne. So there are 8 elements in the second period. The third period begins with sodium and ends with argon. How many elements are there in this period? In period 3, it starts with sodium or Na and it ends with argon or Ar. So there are 8 elements in the period 3. The periodic table has the following vertical columns called families or groups: 8 A groups and 8 B groups.
The group B elements differ from the rest because they are heavy metals. In period 3, there are 8 elements, starting with sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. Elements with atomic numbers 57 to 71 forms the lanthanide series or rare earth elements, while those with atomic numbers from 89 to 98 forms the actinide series or radioactive elements. What is meant by rare earth elements? It is a group of chemical similar metallic elements comprising the lanthanide. They are not specially rare, but they tend to occur together in nature and are difficult to separate from one another. What is meant by radioactive elements? Radioactive elements are made up of atoms whose nuclei are unstable and give off atomic radiation as part of a process of attaining stability. The emission of radiation transforms radioactive atoms into another chemical element which may be stable or may be radioactive such that it undergoes further decay. The 8A groups are further divided into 3 subgroups. How do 1A and 2A differ from the other group A elements? The elements in group 1A are called the alkali metals. The elements in group 2A are called the alkaline earth metals. Why is hydrogen separated from the rest of 1A? It is because hydrogen is not a metal but a gas. Hydrogen is above group 1 because atoms of the alkali metals also have only 1 electron in the outer level. How do group 3A to group 7A differ from the other group A elements? The group 3A is the boron group and the group 7A are the halogens. Boron group element any of the 6 chemical elements constituting group 13 or group 3A of the periodic table. The elements are the following. The group 7A elements has 7 valence electrons in their highest energy orbitals.
Good morning everyone, this is Zynab Angelie Galaroza speaking, and I will be explaining to you number 9, which tackles about the group 8A elements that is located at the last column to the right, and those are helium, argon, neon, krypton, xenon, and radon, and those are called the inert gases. What is meant by inert gas? So an inert gas is a gas that does not form any chemical reactions with other chemical substances, and therefore it does not form chemical compounds. Also, it is complete in valence shell. So among the inert gases that have been mentioned, I will choose one element to identify its general characteristics and where it is found in nature, and that would be neon. Neon is colorless, tasteless, odorless, chemically inactive, changes reddish-orange in a vacuum tube, and it has the lowest liquid range. It is found in very small traces in both Earth's atmosphere and Earth's crust.
Again, this is Zynab Galaroza speaking, and for this activity, we are asked to write down the first 20 elements, starting with lithium and proceeding from left to right, row by row, in order of increasing atomic numbers. And we are also asked to include the following information about each element, which are the chemical symbols, the atomic number, the atomic mass. But since there are too many and it will take a lot of time, I will only explain 5 elements among these 20, and the rest can be seen on the screen. Starting with lithium, the chemical symbol is capital letter L and small letter I. The atomic number is 3. The atomic weight is 6.9 grams per mole or 7 grams per mole. The density is 0.534 grams per cubic centimeter. The melting point is 180.5 degrees Celsius. The boiling point is 1342 degrees Celsius. Next, we have beryllium. The chemical symbol of beryllium is capital letter B and small letter E. The atomic number is 4. The atomic weight is 9 grams per mole. The density is 1.848 grams per cubic centimeter. The melting point is 1278 degrees Celsius. The boiling point is 2970 degrees Celsius. Next, we have boron. The chemical symbol for boron is capital letter B. The atomic number is 5. The atomic weight is 10.8 grams per mole. The density is 2.34 grams per cubic centimeter. The melting point is 2075.8 degrees Celsius, and the boiling point is 3926.8 degrees Celsius. Next, we have carbon. The chemical symbol for carbon is capital letter C. The atomic number is 6. The atomic weight is 12 grams per mole. The density is 2.26 grams per cubic centimeter. The melting point is 3550 degrees Celsius, and the boiling point is 4827 degrees Celsius. Nitrogen. The chemical symbol for nitrogen is capital letter N. The atomic number is 7. The atomic weight is 14 grams per mole. The density is 0.001 grams per cubic centimeter. The melting point is negative 209.9 degrees Celsius, and the boiling point is negative 195.8 degrees Celsius.
And to conclude this activity, the periodic table is indeed have a very wide scope to learn, and it plays a very important role, especially in our course, which is the medical technology, for we are exposed in the laboratory. It is known to be the most important reference in chemistry. In fact, the periodic table is so accurate that it allows scientists to predict the chemical and physical properties of elements that hadn't yet been discovered. In laboratories, the periodic table plays an important role in helping scientists anticipate the types of chemical reactions that could occur and balance equations accordingly.